Hi guys. Okay, so we are in your note packet. We completed the first 2 pages, right? And then you guys had a small, short worksheet to do where you had to actually solve the questions on your Chromebook and use the annotation ability with the PDF. So now we're going on to simplifying radicals. So not all numbers are perfect squares. So like 1, 9, 4, 16, 25, those are all perfect squares. But a number like 32 is not a perfect square. So what that means is like I can't do 4 times 4 to equal 32 or 5 times 5 or 6 times 6. I do know though that 5 times 5 is 25, right? And 6 squared, 6 times 6 is 36. But we have 32, which is somewhere in between 25 and 36. So I can estimate that the square root of 32 will be somewhere in between 5 and 6, okay? But what we're going to learn today is how to simplify radicals. And again, this should be a review, so you should have seen this in the past. So it's just a quick review. And there's multiple ways to do this. But what I do not want for you to do is I do not want for you to use a calculator. If you have the yellow calculators, the TI-30, I don't remember, they're TI-30 something, but they're like those yellow ones. I know that they recommend those in middle school. Do not use that calculator because it will solve the problem for you. And that is not the point of this. And so I need for you to understand how to reduce radicals without the use of a calculator. And this will be a skill that you need to know later on in the course. So make sure that you're paying attention to this now and that you're not just using a device that will do it for you, okay? So what you're going to do is they have some examples up here. You're going to get it into its prime factorization. So prime factorization. That should be a word from middle school. Prime factorization is where I break a number down into its last row where all the numbers are prime numbers, like 1 is prime, well 1 is special, but 2 is prime, 3 is prime, 5 is prime, because only 1 in itself multiply to that number. So 1 times 5 is 5. Those are the only factors that go into 5, so that's what makes 5 prime. So you're trying to find its prime factorization. So for instance, if I'm looking at 28, I break 28 down. I know that 7 times 4 equals 28. So if you struggle with your multiplication facts, this will be somewhat of a struggle, so you really have to know your multiplication facts. 7 times 4 is 28. Well, 7 is actually prime, but 4 is not prime. So I bring 7 down, because it's prime. It doesn't break down anymore. If it broke down, it would break down into 7, 1, which is the same thing, right? But 4 breaks down into 2 times 2. Both those 2's are prime. So this is its prime factorization string, okay? 7 times 2 times 2. What you then do is you look for a pair. So I have a pair of 2's, okay? If I have a pair, 1 comes out and the other one is gone. 7 does not have a pair, so it stays under the radical. The reason being is because if I have 7 times 4, 7 is not a perfect square, so it stays under the radical. But what is the square root of 4? Well, it's 2. It breaks down into 2 times 2, so the square root of 4 is 2. So that's why the 2 comes out. This is the answer reduced. Now we said earlier that we could figure out what numbers it's in between. Well, again, isn't 28 somewhere in between 25 and 36, right? So my answer should be somewhere in between 5 and 6. Well, 2 is not between 5 and 6. But if I type in 2 square roots of 7 on my calculator, I get a 5.29 number. So I get a number that's in between 5 and 6 as a decimal. We do not want decimals right now. We want reduced radicals. This is the more accurate answer because what happens on here is this is most likely a non-terminating decimal sentence, meaning it will never end. And so the calculator itself is actually rounding it, and it goes on and on and on and keeps going. So a more accurate answer is the reduced radical because we're not leaving off numbers that we've rounded, okay? So 54, what they did is they broke it down into 9 times 6. Now, 9 and 6 are not the only factor pairs. We call that a factor pair. So what times what equals that number? They're not the only factor pairs of 54, okay? I know that 2 times 27 equals 54, so I could have broken it down that way. So you may break it down a different way than somebody else, but your prime factorization string at the very bottom will always be the same because it's the same numbers that are prime that we multiply to equal that number. I then break down 9 into 3 times 3. 3 times 3 equals 9. I break 6 down into 3 times 2. I have a pair of 3s, so a 3 comes out. This does not have a pair, and this does not have a pair, so they both stay under the radical. But what you're going to do with them is you are going to actually multiply them together. So you're going to do that 2 times the 3, and it becomes 6. So your final answer reduced down is 3 square roots of 6. 150, they broke it down into 15 times 10. 15, they broke down into 3 times 5. 10, they broke down to 2 times 5. I do not have 2 3s, so 3 stays in there. I see I have a 5 here and a 5 here. They don't have to be side by side. They can be anywhere in that factor string. So as long as it has a buddy and a pair, that we're good to go. So 5 times 5 is really 25, right? So 25 actually goes into 150. The square root of 25 is 5, so that's why this 5 is out front. This 2 does not have a pair, so it stays under. So I multiply that 3 and that 2, and it becomes 6 underneath. 720, so this is a big number. Breaks down to 72 and 10. 72 breaks down into 9 and 8. 9 breaks down into 3 and 3. 8 breaks down into 2 times 2 times 2. It actually breaks down into 4 times 2, but you'll notice that a lot of times on 8, if you just want to go ahead and break it down into 2 times 2, which is 4 times 2 is 8, that's its prime factorization. So that's what they did here. This 2 is prime, so it just comes down. This 5 is prime, so it just comes down. One thing I need for you to note, I sometimes get, or see it a lot, these two numbers being left off and not brought down. You have to bring them down, okay? They are prime, just bring them down with however many levels you have. I have a pair of 3s, so 3 comes out because 3 times 3 is 9, square root of 9 is 3. I have a pair of 2s, so 2 comes out, 2 times 2 is 4, so we have another 4. And then I have another 2 here, pair of 2, so that's this 2. I have 5 left over, it doesn't have a buddy, so it stays in the radical. But now what I need to do is I need to multiply these. So I have 3 times 2 times 2. That would be 6 times 2 is 12. 12 square roots of 5. Okay? So let's try some of these. All right. Square root of 9. Guys, we should know that one, right? That's a perfect square. That's just 3. So you're done with that one. 32 is not a perfect square, so we're going to start breaking it down. Again, there's multiple ways. You could break that down to 16 times 2. Or you could break it down to 8 times 4. I'm going to go ahead and break it down into 8 times 4. 8, like we said before, breaks down into 2 times 2 times 2. 4 breaks down into 2 times 2. So 2 times 2 times 2 equals 8. 2 times 2 equals 4. I have a pair of 2s, so I'm going to circle those, and I have another pair of 2s. So 2 times 2 is 4. Square root of 4 is 2, so 2 comes out. Same thing here, 2 comes out. That's gone, that's gone. I have a 2 left over that doesn't have a buddy, so it goes under the radical. You do not leave the answer like that. You need to simplify the front of it. So 2 times 2 is 4. Square roots of 2 is your answer. All right, let's try 50. Break it down. 25 times 2. Not times 5, but times 2. 5 times 5 is 25, so I'm going to break that down. Bring down my 2. I have a pair of 5s, so I'm going to circle those 5s. A 5 is going to come out. Square roots of 2 stays under. That is your final answer. All right. Square root of 80. Break it down. I'm going to break it down to 8 times 10. Could you break it down differently? Sure. Go ahead. Do it like 4 times 20. You could break it down into 4 times 20. And you should see at the end, our prime factorization string at the very end will be the same. 8, we talked about earlier, breaks down into 2 times 2 times 2. 10 breaks down into 2 times 5. I have a pair of 2s. I have another pair of 2s, and 5 is left by itself. So I'm going to bring out a 2 from this pair, gone. Bring out a 2 from this pair, gone. Left with the square root of 5. I'm going to actually go ahead and multiply those two things. 2 times 2 is 4. Left over with square root of 5. 72 breaks down into 8 times 9. 8 breaks down into 2 times 2 times 2. 9 breaks down into 3 times 3. I have a pair of 2s and a pair of 3s. So a 2 is going to come out, a 3 is going to come out. That's gone now. And I'm left with square root of 2. 2 times 3 is 6, so 6 on the outside, square roots of 2. All right, we're going to keep going. 120. 120 breaks down into 12 times 10. Again, you have to know your factor pairs, so your multiplication. 12 breaks down into, I could do 3 times 4, I could do 6 times 2. I'm going to go ahead and do 6 times 2. 10 breaks down into 2 times 5. 6 is not prime, so I have to go again. 6 breaks down into 3 times 2. 2 is prime, so I bring it straight down. 2 is prime, so I bring it straight down. 5 is prime, so I bring it straight down. I have a pair of 2's, and that is my only pair there. Okay? 2 times 2 is 4. Square root of 4 is 2. Big square root symbol. That's gone. I'm left with 3, 2, and 5 on the inside, and that is okay to have that many numbers on the inside. But make sure that you multiply them now. So 2 is on the outside. Square root of 3 times 2 is 6. 6 times 5 is 30. Okay? There's not a lot of room here, is there? 68. Let's break it down into 34 times 2. 34 breaks down into 17 times 2. Bring down this 2. 17 is actually prime. So I have a pair of 2's. The 2 comes out. 17 stays under. Put a line under 8, 9, and 10 real quick for me. Let's skip down to number 11. There is a number out front. No different, guys. Okay, we're going to keep that number out front. We're going to just break down the number under the radical. Breaks down into 4 times 3. 4 breaks down into 2 times 2. Bring down my 3. So now what happens is I have a pair of 2's. Do not forget about that 3 that's on the outside. Throw that 3 back out there. It's on the outside. In addition, I now have this 2 that comes out there. I have radical 3 left under. 2 times 3 is 6, square roots of 3. Okay? Let's do another one of those. 48 breaks down into 4 times 12. 4 breaks down into 2 times 2. 12 breaks down into 6 times 2. Don't forget there's a 5 out front. We don't need it quite yet. Not all these are prime. 6 is not prime, so I need to bring them straight down. 2, 2, 3 times 2 equals 6. Bring down my 2. Pair of 2's, 3 is left over. Bring my 5 out. Take a 2 from here. Take a 2 from here. Left with square root of 3. 5 times 2 is 10. Times 2 is 20. Left with square root of 3. Underline 13, 14, 15. Go ahead and pause me. I want you to do 8, 9, 10, 13, 14, and 15 on your own. When you're done, unpause me so you can check yourself. All right, I'm going to quickly go through those. 200 is 20 times 10. This is 2 times 10. I'm actually going to bring down my 10 here also. The reason being is I have a pair. So I can take out that 10 and I have square roots of 2. You probably broke down those 10s into 5 times 2 and 5 times 2. And then you saw that you could bring out a 5 and a 2, which just makes that 10. Here I have 18 times 10. 9 times 2. 2 times 5. 9 breaks down to 3 times 2. 3 times 3, bring down my 2. Bring down my 2. Bring down my 5. Pair of 2's, pair of 3's, they both come out. I get 1 3 out, 1 2 out, which makes 6, square roots of 5. 33 breaks down to 3 times 11. They're both prime at that point. There's no pair, so your answer on this is actually just square root of 33. 76, I think 76 divided by 4 would be 19. This breaks down into 2 times 2. 19 is prime. Bring it down. I have a 2 on the outside, and I'm bringing another 2 out, so 2 times 2 is 4, square roots of 19. Here, we're going to break this down to 16 times 2. 16 is 4 times 4. Bring down my 2. I have a pair of 4's at that point. You can stop if you have a pair of 4's and the other number is prime. So I'm going to bring a 4 out, so 4 times negative 3 is negative 12, square roots of 2. All right, a couple more, guys, or one more. 80, 8 and 10. 2 times 2 times 2. 2 times 5. Pair of 2's, 2 times 2. Both comes out as 4 times that 5 is 20. Square roots of 5. Barely made it in my time. Thanks, guys.